Okay, so for packets 15 and 16, we're going to be doing a little review on quadratic functions. This is in your notes if you need to look back at it. But these are the basics, and the vocabulary is a huge part of quadratic functions. Okay, you can know how to do this stuff, but if you don't know what they're asking, then you won't get it right. So big-time vocabulary words that we need to know are the roots, solutions, zeros, and x-intercepts, the axis of symmetry, and the vertex. In fact, question number 2 on your benchmark was just a vertex question, which is a very easy question if you know what it's asking. So first vocabulary word that I want to go over is the axis of symmetry. So if I look here at the axis of symmetry, on this graph right here, on this parabola, this is a parabola because it's a U-shaped figure, I want to look at where that line of symmetry is. The axis of symmetry, think of line of symmetry, mirror image, where I can just cut it in half and they'll be the exact same on both sides. So I've drawn this dotted line down the axis of symmetry, and again, that's where you can cut it in half. The equation of a vertical line is always going to start as x equals. Okay? Horizontal lines would be y equals, just y equals a number. But for a vertical line, it's going to be x equals a number. So what I do is I draw my line down the middle of my parabola, and then wherever it crosses the x-axis is what x equals. So x equals 2 is the equation for the axis of symmetry of this parabola. So any other parabola you have, you draw your line down the center, and you look at where it crosses the x-axis for what the equation would be for x equals. Okay, so axis of symmetry. The other vocabulary word that I want to go over is vertex. All right, vertex is going to be the lowest or the highest point on the curve. And so for this parabola, on this example, the vertex is going to be the lowest point on the parabola. That's called the minimum point. So vertex here is the minimum point. If my parabola was facing the other direction, like so, then the vertex would be up here, and that would be my highest point, which is also called a max. Okay, so the way we find it is a point. We label it as a point, x, y. And so this point happened to be at -2, -2, and that is the vertex. So on problem number 2 on your benchmark, you would plug the quadratic into your calculator under y equals, and then you go look at your graph and figure out which point of your answer choices could be the point that is the vertex. So just knowing that vocabulary will help you get one right. All right, the next vocabulary that we want to talk about are roots, solutions, zeros, and x-intercepts. First, we have to know that this is all 4 of these things mean the exact same thing. They mean, where does my graph cross the x-axis? What is my x value when y is 0? Because that's what an x-intercept is. I haven't gone up or down on my axis, on my y-axis, when I'm crossing the x-intercept. So y is 0. So again, I'm looking for where it crosses the x-axis, and these are the 2 points there, and another way of saying that is what is the x value when y is 0. So first, we know that I can always have 0 solutions, 1 solution, or 2 solutions. 0 solutions look like when I have a quadratic that does not cross the x-axis. 1 solution is where it hits only once on the x-axis. And then 2 solutions would be like this one right over here, where it crosses twice on the example here. All right, so now that I know if I have 0, 1, or 2 solutions, then I can look and see what those values are. And what I always do is I plug in the equation into my calculator under y equals, and then I look at my graph first every time so that I can see how many solutions am I going to have, and approximately where should I look in my table. So I always use the graph just for that, and then I use the table to tell me specifically what is that x value when y is 0. So I look for the 0. Now that we know the vocabulary, solutions, roots, zeros, and x-intercepts, and we know that all 4 of those words mean the exact same thing, we're going to actually look more into how we find them. We can have a quadratic that is set equal to y, or it can be set equal to 0, but everything has to be on the same side of the equal sign. Once it's on the same side of the equal sign, we can plug it into y equals. And sometimes you might have examples where they use different letters besides x, like T or C, any kind of other letter. Well, just replace that with x when you plug it into your calculator. All right, so right now I've got the quadratic. I know it's a quadratic because it has a squared term. I go plug this quadratic into y equals, and what comes up on my graphing calculator is this parabola. Once I see that parabola and I'm trying to find the solution, that tells me that there are 2 solutions. Okay, I see it crossing the x-axis twice. And I go look at what values they are. It's at -1 and at 3. I can write that 3 different ways. I can write that as a solution set where it's in brackets. Make sure it's not in parentheses because that would be a point. This is just a solution set saying -1 is your x value and 3 is your x value where y is 0. You could also write them as points. Okay, this point is -1, 0. This point is 3, 0. Make sure when you're writing the solutions, roots, zeros, or x-intercepts as a point that the x is the number and y is 0. And the last way you could write it is just x equals. So all 3 of those ways are ways that you'll typically see solutions, roots, zeros, and x-intercepts written. Now the other way, if they just gave me this equation, this quadratic equation, I could enter it into my y equals again, and this time look at my table instead. And looking at your table, you're looking for where y is 0. So the numbers that I've circled in red would also be your solution. So I would scroll in my table. So typically what I do is I'd enter it into my calculator. I would look at my graph to see how many solutions, which I see that there's 2, and then I look at my table to actually find specifically what it is. Now, I have written here, from a table we are looking for the x value and y is 0. This is why solutions are also called zeros. You can put this into your equation, y equals, in your calculator and look at the table to find them. And so that's what I just went over. Now, I do want to mention that there's different ways that you'll see these asked. They'll give you a quadratic equation and then ask you to find either a solution set. Sometimes they ask, like in this example, sometimes they will ask me for the points that are the solutions, or zeros, or roots, or x-intercepts. And then sometimes they ask me which are the factors. And this is the one I specifically want to look at. So if they ask me which are the factors of this quadratic, what I would there's 2 ways you can solve this. The first way is you can multiply using the box or FOIL. Because what factors are 2 things that are multiplying together to get an answer. So all of these are binomials times binomials. Okay, 2 terms times 2 terms, meaning I can't use my exponent laws. I have to use FOIL, or distribute twice, or my box method. These, even though they're not multiplied out right now, they are still quadratics. Because all of these, once I multiply them, will give me a quadratic. So I can enter this into my calculator and look at my graph as well. So factors that are 2 binomials being multiplied together are just the same thing as the quadratic. It's just we haven't multiplied them yet. So one way you can see which one the answer is to, like I said, multiply them out. Use distributive twice or use your box method. And when I did that, I got to see that this actually ended up being the 2 factors that would multiply out to get me my quadratic. The other way you could do this is plug the quadratic that they give you, which is y equals x squared minus 2x minus 3. I could take this quadratic and I could actually put that into my calculator. I could take my first answer choice and put that into my calculator and see if they are the same graph. If they're the same graph or have the exact same values on your table, then they're equivalent, meaning they're the same thing. So I plugged in A into my calculator and they were not the same graph. I plugged in answer choice B under y equals in my calculator, and it was not the same answer. Now for answer choice C, again, I had this first equation in my calculator for y1, I plugged this one in for y2, and when I pushed graph, they are the exact same graph, meaning they are equivalent. And so that's how I knew C was my answer. I also looked at my table, and the y values were the exact same all the way through my table, again, meaning that they are equivalent. So you've got 2 ways to solve these. First way, multiply them out using box or FOIL and see if they equal each other. The second way, plug them both into your calculator. This into y1, your answer choice into y2, and see if they're the same. If it's not the same, take this out of y2 and plug the next one in, and then plug the next one in, and keep plugging them in until they are equivalent. And so again, I put that right here in your notes. So for some practice on this, let's look at doing some examples. We are going to look at number 1. All right, I want to find the vertex and the axis of symmetry. The vertex is going to be the highest or lowest point on the curve, which is right here. This ends up being a max. And we need to find that exact point, which is -3, 3. So that would be your vertex. Your axis of symmetry is going to be what cuts this parabola right in half, which is right down the center. And we write that as x equals, an equation, x equals. And what does x equal? It crosses at -3. So x equals -3. Okay, again, I'm going to find the axis of symmetry and the vertex. So, oops, here we go. The vertex was going to be, again, this is your max point, and that's going to be at -2, 2. We write it as an ordered pair. And your axis of symmetry is going to be what cuts this parabola right in half. And it's an equation as x equals, and this is x equals -2. On this example, we want to actually find the x-intercepts, or roots, or solutions, or zeros, however you want to call it. So I'm going to look at where it crosses the x-axis. But the first thing that I see is that here's the x-axis, and the parabola never crosses it. So I would have no solution. This is an example that has no solution. On this quadratic, I do see that the parabola is crossing the x-axis, and that's what I'm looking for when I'm trying to find the roots or solutions or zeros or x-intercepts. And so I look specifically at where it crosses. Now these don't happen to cross at full or whole numbers, but that's okay, I can estimate. This has one crossing at about -3.8, and the other one is crossing at about, it's getting really close to 0, so we'll just say at -0.2. Those are again, estimations. You could also write them as fractions. But either way, I know what the x value is. I just wrote these as x equals, but I could also write this as a solution set. Make sure you use brackets for solution set. Oops, I just used a parentheses. And I could also write them as points, which would be -3.80 and -0.20. Make sure you're writing them as the x value and the y as 0. Okay, now sometimes you'll just have questions where they don't give you the graph, they just give you the quadratic. So it says find the roots of the following quadratics. Well, the way I would do this is I would first take my quadratic and I would plug it into my calculator under y equals. Then I'm going to hit graph, and when I did that, I got a graph on my calculator that has it crossing through negative, and I didn't do that exactly, but it was crossing through -1 and -4. I also was able to look at my table. And what I do is I look at my graph and I just look, okay, that looks approximately like I had 2 solutions, and this tells me about where they were. Then I hit second graph and go look at my table, and I actually go make sure. And sure enough, in there I had -4, y was 0. And then I had other numbers, and then it eventually led to -1 was 0. So look at your graph to see how many solutions, then look at your table to find the specific value of those functions where y is 0. I hope this helps. Quadratics, again, main thing is vocabulary. Know that the vertex is the highest or lowest point on the curve, that the axis of symmetry is cutting it in half. It's an equation as x equals, and that roots, zeros, x-intercepts, and solutions all mean where does the graph cross the x-axis and what is the x value when y is 0. Okay, and the last vocabulary that you do need to know is factors. Factors means 2 numbers that are being, or expressions that are being multiplied together to get the quadratic. And so factors, which are written, let me move this up, factors which are written looking like this, can be multiplied out to get a quadratic. So this is a quadratic. I just haven't multiplied it yet. But either way, I can enter that into my calculator and see if that is equivalent with the quadratic that they gave me. So those are the vocabulary words that you need to know, and you'll do great.